Hello again. We're going to have some clues for your homework problems. These are not the same as your homework problems, but just to give you a feel for what's going on. Alright, so in the first one, we need to find beta, ARL 0, and ARL 1. So we need to have a hypothesis test. In this one, we're going to have mu equal to 8 versus H1 mu not equal to 8. So we know that alpha is equal to 0.10, sigma is equal to 0.05, and n equal 25. So we know now that the mean of the process has shifted from 8 to 8.02. So we need to find all those things. And the first thing that we need to do is find the appropriate z at alpha over 2, which is our lead-in on our formula. So we're going to take 0.5 minus alpha over 2. And that's going to give me 0.5 minus 0.05, or 0.4500. Okay, that's a probability. You look at the z table in the middle, find the hit closest to that, and you'll get the 1.64. Okay, now the beta formula is the phi, capital Phi, of z alpha over 2 minus delta times square root of n over sigma minus phi of minus z alpha over 2 minus delta times square root of n over sigma, where delta is mu1 minus mu0. Okay? For this particular problem, let me scroll up. You're going to have delta equal to 8.02, that's your new one, minus 8 equal to 0.02. The z, which we just found a minute ago, is 1.64. We know that sigma is 0.05, and we know that n is 25. So let's go ahead and start putting this stuff in the formula, and we're going to have beta equal to phi of 1.64 minus 0.02 times square root of 25 over 0.05 minus phi of minus 1.64 minus 0.02 times square root of 25 over 0.05. So that's going to give me phi of 1.64 minus 2 minus phi of minus 1.64 minus 2, and that's going to give me phi of negative 0.36 minus phi of minus 3.64. Okay? Now, we need to go into R to evaluate these, and if you look on the next page, it has it. Let me just show you how to do it. So you have P norm of minus 3.6, and that gives me 0.3594. I have P norm of minus 3.64, and that gives me 0.0001. So if I take these and subtract them, I have 3594 minus 0.0001, and that gives me 3593. So that's my beta value. Okay? And if you scroll down to the next page, that just has it in there. Okay? So beta is equal to 0.3953, which is not good. Alright, what is the power? Power is, of course, 1 minus beta. In this case, 1 minus 0.3593, or 0.6407. Okay. Let's go ahead and get the ARL 0. And that's the average number of points we expect to be in control from our X-bar control chart. That should be closed paren. Okay, the formula is just 1 over alpha. This is not interesting. It's 1 over 0.1, or 10 control points. Notice that this is an average, so it doesn't have to be a particular value. It can have decimal extensions. Okay, similarly, the ARL 1 is the average number of points we expect that will have 1 point out of control. So we're going to have 1 over 1 minus beta, which is 1 over power, and that's going to be 1 over the 6507, and that's going to give me 1.56. Should that be 6407? Yes, should be 6407, but just use what you got. Okay, sorry. Let's look at the Weibull distribution. Okay, so what we do with this one, we're looking for the mean, and that's the mean time to failure. So here's the formula. We have mu, because we're looking for the mean, is equal to theta times the gamma function of 1 plus 1 over beta. Okay, now this is a separate problem from the one that we just did, so this is a different beta, so don't get choked up over that. So let's say that we have an example in which theta is equal to 75 and beta is equal to 1/2. I want to find the mean time to failure, assuming a Weibull distribution. So my theta is 75, my gamma is 1 plus 1 over 1/2. I still have 75 times gamma of 1 plus 2, and that's 75 of gamma of 3. But we know that gamma of r is r minus 1 factorial when n is an integer. So that way we can solve this as 75 times 3 minus 1 factorial, or 75 minus 2 factorial, which is 75 times 2, which is 150. Okay, good luck on your homework.